and collective progress in the quantum era. I would like to express my sincere gratitude to the members of KPS IOIQ committee for their dedication in making this event possible. May today's forum to be remembered as a milestone in our collective journey toward a brighter future for quantum science across our region. Thank you very much.
Thank you. We have another welcome remark by Deputy Minister of Science and ICT of Korea, 강상보.
Researchers from APEC countries, President Yoon-Jin, the Korean Physical Society, esteemed physicists and quantum science experts from the Korea and abroad. I also extend a warm welcome to all participants joining us today. It is my great pleasure to welcome you all. First, let me congratulate you on the opening of the APEC Quantum Science Technology Forum 2025. I hope this forum will serve as a meaningful platform for researchers driving the advancement of quantum, build global research networks, and exchange creative ideas. I would like to extend my heartfelt congratulations to Professor Peter Joller, recipient of the 14th Benjamin B. Professorship from the Ethiopia Innsbruck, Austria. Professor Joller is recognized as a world-renowned physicist for his pioneering contributions to the concept of quantum simulation using ion traps and ultra-cold atoms, and for advancing the theory of quantum computing and communication. Quantum technology is already demonstrating use cases across various industries, including pharmaceuticals, new materials, and logistics that surpass the capability of conventional AI. It is expected to accelerate the restructuring and disruptive innovation of major industrial sectors. To keep pace with recent developments, the Korean government established a comprehensive national support framework that spans research, development, and commercialization based on the Act on the Promotion of Quantum Science and Technology and Quantum Industry enacted in October 2023. Korea continues to participate in global quantum dialogues and has further strengthened international cooperation through events such as Quantum Korea 2025 and the OECD Korea workshop on quantum held in last June. Building on this experience, we aim to promote the responsible innovation to grow as a leading economy that contributes to the development of global science and technology governance. Moreover, we are committed to supporting international exchange and joint research, enabling young researchers and women scientists to strengthen their capabilities and design the future together on the global stage. International cooperation and exchange among scientists are not only channels for sharing knowledge and experience, but also essential pathways to achieve open innovation. Through this approach, I believe the APEC region can enhance its scientific and technological capacity, accelerate innovation, and achieve inclusive growth. I hope this forum will evolve into a sustainable platform that extends beyond the research collaboration to talent development and industrial partnership among member countries. Korean government will continue to work closely with all of you through investment in research and strengthening international cooperation so that quantum technology can become a key driver of innovation and sustainable development Finally, I would like to express my deep appreciation to the Korean Physical Society and all those who contributed to the successful organization of this forum. I wish everyone here an inspiring time together. Thank you.
Thank you. It's time for our today's first session with the title of Quantum Initiative. Okay, we have 4 speakers in this session, and the first speaker, our speaker is Stephen BARTLETT from University of Sydney, Australia. Please welcome the speaker. Speaker will give a talk 18 minutes, so I'll give you some time.
Thank you very much. Thanks everyone for the chance to speak to you this morning about what's going on in Australia. We've got a large delegation here from Australia all week. We've had a fantastic visit so far. And so on behalf of all of the Australians here, I want to thank you all for the chance to connect with you here in Korea, also the chance to connect with others through this forum and hear about what's going on in the region. Have a great day so far. I'm looking forward to today. So I'm going to tell you a bit about what's happening in quantum in Australia, as well as about Quantum Australia, which is an organization set up in Australia to really bring together the quantum community and to grow our quantum ecosystem and to connect with our global partners. Okay, just a bit about me. I'm Stephen BARTLETT. I'm a professor at the University of Sydney and director of Sydney Nano, our multidisciplinary initiative exploring critical and emerging technologies, which includes quantum. I've also recently established a training center in quantum. We'll hear a bit more about that this afternoon. Gavin's going to tell us about the training activities happening in quantum in Australia. There's lots of research activities going on, and if you have any questions or want to talk more about partnerships with the University of Sydney, I'd be happy to have those discussions later. But what I'm going to talk about today is Quantum Australia. So what is this? This was established by the Australian government just in last year, in 2024, to really bring together the growing quantum ecosystem in Australia, which historically has been very research-focused, really based on a lot of excellent research activities at universities over many years, and to bring that community, that research expertise together with industry, with government, with defense, and with our global partners to really try to bring about the transformative change we see that quantum technologies offers for the future. So to really translate that research excellence in Australia out into the broader economy. So it is a partnership, a consortium consisting of 13 universities in Australia with quantum experts, federal and state governments, industries, and other key stakeholders to really bring together the experts in Australia around quantum to help to grow this ecosystem. So it is structured as a national body. It has a headquarters, but it also has nodes in many of our states where all of the quantum activity is happening. It's led by a CEO, Petra Andren, and an executive team and overseen by an independent board, which I sit on. How did Quantum Australia come about? Well, in 2023, the Australian government announced its national quantum strategy, and that was really the roadmap for Australia to look at translating our research strength in quantum into a quantum industry for the nation. So in this strategy, of course, there's lots of focus and effort on building our R&D capacity and looking at developing quantum technologies and getting them out into society. But more than that, there's several other pillars. We wanted to continue to grow our fantastic quantum workforce in Australia, so we focus on what we're going to do on training and skills. An effort around standards and frameworks, and this is something, of course, we want to do with our international partners. I'll say a bit more about that. A clear plan and a way of funding the infrastructure and materials that we're going to need for quantum technologies. And then finally, a broader structure to make sure that this new quantum ecosystem is going to bring benefits for all Australians. So really bringing about equal opportunity and to ensure that we have a trusted and ethical framework to build this inclusive quantum ecosystem. So it's a fantastic and very ambitious strategy. And one part of that national strategy was to create a national industry growth center. And so that's what Quantum Australia is. So Quantum Australia is delivering on a piece of this national quantum strategy to really enable this ecosystem. And so there are three parts to Quantum Australia. One is growing that ecosystem, and that is primarily an educational piece for industry, for government itself, for defense, for other stakeholders. What are the opportunities in quantum? What can this mean for the resources sector, for the agricultural sector, for the health sector, for the finance sector? And really informing, starting those conversations. So there's a big component around that ecosystem development, and within that, of course, is a big focus on connecting with our international partners. We have a partnership program which is trying to match up the quantum experts that we have within Australia, within Quantum Australia, in our universities and our labs, matching that expertise up with the opportunities that exist out there in the broader economy. And then finally, I'm quite excited about this new venture program. We have a lot of success in Australia around quantum startups and spin-outs from our universities, really starting to see our research strength getting translated into new companies and new ventures. And we're looking for a real step change in that. So enabling many new spin-out companies and startups in quantum to get off the ground. Quantum Australia's been up and running for about a year now, and already, especially in the quantum ecosystem space, there's been a huge amount of activity, lots of events connecting together researchers with end users, not just talking amongst the quantum experts, but talking with the broader community about what those opportunities are. And I should just finally emphasize that these three different programs are actually very, very highly integrated. There's a whole structure behind this to make sure that when we introduce a new company or a new strategic partner to the opportunities around quantum, we're enabling them to grow their expertise, to start to connect with relevant partners, to become experts themselves, and eventually start advocating within their sector for the opportunities in quantum. Okay, so that's a bit of an overview of Quantum Australia, the organization. So let me step back a bit and talk about quantum in Australia at the moment. Where are our strengths? What's happening, especially in this second year, the International Year of Quantum, and to give you a bit of an update. Australia has a very long academic research history in quantum. Some of our scientists got in very early in the area of quantum, even in the 90s, and the federal government invested quite heavily early on, creating research centers and supporting things in academia back into the 90s and over the last 25 years. Looking up the number here, about $2.3 billion in public funding towards fundamental university-based research in quantum over the past 25 years. And that has led to a lot of the research strength that we have in the nation at the moment. So we do have a lot of leading research groups, many academics, and a lot of the people trained, I think you've seen them around the world, have had some connection, whether they've been trained in Australia or done some research in Australia over their career. A lot of people have, in the quantum field, have connected with Australia at some point because of that long history. With a bit of a survey at Quantum Talent internationally, have discovered that we are the 5th largest source of quantum talent globally, despite Australia being a relatively small nation in population. That research strength at universities has, as I mentioned, really started to map out into industry. We have quite a few startups, so there's 40+ quantum-focused businesses, primarily in the hardware space, but increasingly a lot in software and adjacent industries. A lot of these have come about just in the past few years, and you're going to see many more in the next few years, in part because of the activities by Australia. If you were interested in more details about that, I encourage you to have a look at the the industry capability report that was put together by Quantum Australia and Austrade, which is the federal government's trade ministry. A fantastic report, really giving some more detail to what I just mentioned there. So please grab that. If you want to delve into some more detail about where are those quantum experts and what are they doing, have a look at Australia's quantum ecosystem map developed through that same process. As we've heard, 2025 is the International Year of Quantum, and there's been some really exciting developments in Australia just in the past year. So let me just pick out some highlights. The first two relate to the Australian government's really flagship industry and manufacturing policy, the National Reconstruction Fund, a $15 billion investment into manufacturing capabilities in Australia, of which $1 billion is earmarked for emerging technologies, including quantum. And already, some of the first investments from this significant fund have gone into our quantum companies. So just highlighting their Quintessence Labs, which is based in Canberra and is actually one of the world's sort of longest standing, oldest quantum startups, focusing on quantum cybersecurity. They received $20 million in funding, including $15 million out of this National Reconstruction Fund. And another investment there is in a diamond quantum foundry to support another one of our fantastic startups, Quantum Brilliance. And that was co-investment between this National Reconstruction Fund and the Victorian government. Another highlight, we have one of our more mature quantum companies, Q-Control, is now really a global force. They, in the last year, just closed their Series B round, which is the largest Series B round for quantum in the world, at $113 million. Huge success for one of our most successful companies. Again, a big global success for some of our companies, Silicon Quantum Computing and Dirac, both pursuing semiconductor quantum computer architectures. They are both supported within DARPA's Quantum Benchmarking Initiative, and that is supporting globally a handful of companies to develop utility-scale quantum computers over the next decade. Fantastic to see two Australian companies really involved in that a major investment by the Australian government and the Queensland governments into Quantum to bring a manufacturing capability to Australia, to Brisbane. So nearly $1 billion Australian investment into that company to build a manufacturing capability near Brisbane Airport, and that is currently underway. They're building this quantum computer facility in Brisbane right now. Fantastic to see that scale of investment happen. It's going to put Australian quantum manufacturing on the map. And then finally there, a world-class recognition for researchers at the University of Melbourne, the Gordon Bell Prize for their work in quantum chemistry. Using classical approaches there, but looking at the capabilities of what quantum is going to be able to offer for solving problems in quantum chemistry. So just a bit about the trajectory. Where do we see this momentum going? A number of reports by the Australian government and CSIRO looking at what is that opportunity for Australia by 2045. And we really see the opportunity to grab a significant share of the global quantum computing market. So to not only offer something as a domestic capability, but to put ourselves on a global map. And that's, of course, new industries, new jobs, and a big impact on our GDP. Just coming to the end, I did want to mention some of the connections that we currently have with Korea around quantum. I would say, and we've seen that this week, there's a lot of interest and excitement about exploring partnerships between Korea and Australia in quantum, but it is very early days. We don't have a number of sort of significant outcomes yet, but we do, I think, have the groundwork needed to develop things in the future. So along the lines of sort of laying the groundwork for future partnerships, there have been there's an agreement in place to really look at those standards and the framework for critical and emerging technologies. So that includes AI, but as well as quantum. We have that dialogue between Korea and Australia experts in those areas. There is a significant increased investment by Korea and Korean companies in Australia. There is, I think, a recognition that there are real opportunities in Australia for Korean companies, and we're hoping that that can feed into quantum. And just finally, this is part of a sort of a global dialogue amongst a collection of strategic partners, including Korea and Australia, but really led by the US and a number of other allied nations to figure out what is a plan for us to work together to achieve our quantum ambitions. If you're interested to engage more with Australia around quantum, I would encourage you to look into taking part in Quantum Australia, the annual conference that brings together all of the quantum ecosystem in Australia. And it really is now quite a global conference. It's been running for many years now, first by the Sydney Quantum Academy, now run by Quantum Australia and moving around the nation. But it is still got at its core that idea of bringing together our quantum expertise together with end users who are interested in the potential of quantum, as well as nations from around the world. We've had many delegations, including from Korea and others from the region. And the next conference is going to be in Adelaide in April, and you can already hop on there, register, and look a bit at the program. So I'd encourage you to look at that. And if you are interested in some more details, please connect with Quantum Australia. A very rich website there, and a great newsletter distributed through LinkedIn. So please just connect with LinkedIn and learn more about the opportunities that Australia has around quantum. Thank you very much.
Thank you for the great talk. We can take a few questions. Otherwise, due to the lack of time, let's move to the next speaker. Thank you for the speaker again. Our next speaker is KAO from National Taiwan University, Taiwan. The title of the talk is Quantum Ecosystem in Taiwan. Let's welcome the speaker.
Thank you very much, and apologies for the delay. So I'm Ying-Jer, and I'm from Taiwan Quantum Program Office, National Science and Technology Council, and my real job is I'm a professor at the Department of Physics at National Taiwan University. So what I'm going to tell you today is the Taiwan quantum system. So Taiwan is actually a late starter in quantum technology, and we only started this Quantum Taiwan initiative at 2022. So this is unlike previous efforts. This is a government, industry, and academia joint effort, and so basically we grouped together the funding agency, the national research institutes, and also industry funded by the government. For example, the E3, we have some representatives here, and also our digital Ministry of Digital Affairs. So basically, we want to develop a critical technology for quantum computing and quantum communications, and we want to have a research hub for quantum computing and communications. The idea is that we want to go through to build a full-stack quantum computer and quantum communication systems, such that we know which part of Taiwan can contribute to these emerging quantum technologies. So we can be a key enabler in the global quantum supply chain. So we have a small office. Our director is Felix Guo, and I'm managing the project. So the mission of our Taiwan Quantum Program Office is several-fold. First, we want to have an integration of efforts from government, academia, and industry. And importantly, there's only one team. Okay, so we want to coordinate, although there are different projects, but there's only one team. And we want to coordinate this research such that scientists cannot be just scientists. They have to build a machine. So that's actually a very hard job to tell a scientist, okay, you are not here to publish paper. You are here to build a machine and develop technologies. So in this sense, we not only involve physicists, we also involve a lot of engineers so they can build the technology. And so importantly, the cross-project integration is our emphasis. And importantly, we want to engage in international collaboration and also develop a strategic partnership. So, as I said, we want to construct a practical quantum system such that we can have a problem-solving capability. So you can question what's the problem that we want to solve, but as I said, we want to develop the full stack. Just run it once and identify the key strengths of Taiwan. So another important thing is we want to cultivate talents for the future. So on the research side, we have funded 20 research teams, and that's through our National Research Center, Academia Sinica, and universities, and also our national labs. So we identify 3 pillars that we focus on. We focus on hardware technology, so basically building qubits and controlling low-temperature controlling electronics and devices. We also develop photonic quantum technologies, and so basically it's the quantum communications and quantum networks. Okay. And we also have put efforts on quantum software and technology and application. So basically, we want to develop the user base, and we want to run through the whole stack. So the division of labor is that we have developed a quantum research base at the Academia Sinica, and so there's the core facilities, and there's a 8-inch foundry which is built superconducting qubits and all the testings. And we also work with E3, which is the under Ministry of Economic Affairs. They sort of like a foundation, and the most famous spin-off from E3 is TSMC. So we're developing CMOS and fabrication technology there. So in terms of international collaboration and partnership, we hold annual Quantum Taiwan Symposium on quantum technologies, and so as I said, we were late starter, so we only have 2 events so far. But I'll tell you more about this. So basically, at the beginning, we realized that Taiwan is a small country. We don't have enough quantum workforce to develop the technology ourselves. So we look for partnership and international collaboration to advance quantum technologies. We also partner with IQM. We bring the Finnish company, so it's we bring we discuss with them, and we bring their commercial 5-cube superconducting quantum computer, such that it's not just buy a quantum computer. We partner with them, and we tailor design the machine such that we can swap their controlling electronics with our own homemade controlling electronics, such that we can make sure that what we develop at home can meet the international standard, can meet the industrial standard. Okay. And in addition, we also emphasize that the shared facility, so we implement and develop platform for quantum subsystems, quantum computer subsystems, because fridge is expensive and it's expensive to run. So we developed this test bed such that people in the country can, whoever researching, they don't have to use their own fridge, and then if they can build their technology, then come to test it. And this also support our international collaboration. Okay, so I mentioned that this year's quantum symposium will be focused on quantum computing towards scalability and connectivity. And so we bring a lot of industry, the frontier industry partners, and they will present their latest technologies and how they, what their future roadmap is. And also we have a forum and invited regional partners to discuss how we can collaborate. And Koreans delegations, I think, will participate in this discussion and forum. So if you're interested, you can scan this QR code. So I briefly mentioned that we want to do this, we want to develop key technologies. Before this program, we don't really have a lot of quantum workforce. We don't even have a lot of quantum researchers. But through this program, we're able to cultivate some talents, and we start to develop a research momentum in certain key strategic areas. So out of this, we already have a 5-qubit homemade quantum computer, although it's a pretty primitive compared to the commercial ones. And we also developed the CMOS control module, and it's on par of what the IBM and so it's on par of and Intel, in terms of quantum CMOS. And this is done by E3, and they're in the process of commercialize this. And we also develop quantum communication, intercity quantum communication using the commercial fiber. So that's our sort of like the current research technology level. So as I mentioned, we also developed at different levels of software from very theoretical studies to think about how to implement quantum error corrections. And so a lot of these quantum error correction algorithms are in the process of programming on FPGA, and maybe in the future will be ASIC. So we also have teams try to optimize the quantum, to bring the silicon EDA standards to quantum development. So finally, I'll tell you a little bit about the education. So we know that talent is very important in the modern, in developing quantum technologies. And so training and promotion becomes important. In terms of talent recruitment, we are actively recruiting faculties who has expertise in quantum technologies, and our funding has attractive salaries compared to other postdocs in the country. Maybe it's not as competitive as in internationally, but we want to attract postdoc students, and also we want to encourage them to go outside to develop international collaborations. So through quarterly events, we have different teams come together and they brainstorm and they share their experiences and encourage their collaboration. And we also invite presentations from companies, so say key size quantum machines and so on. We have an annual workshop, so this is our workforce is researching that they can present their results and have done discussions. And importantly, we have a forum. So this forum is not facing the researchers. The forum is facing the potential industrial partners. So we have forums that we invite the companies, and they send their technical people to come to us, and we'll present some. What is quantum technology? What's the future? And share some experience with them. Also, we emphasize the public outreach. So we have something called QBEAR. So this is sort of like they have a podcast, and they have articles on the web, and they even have a YouTube channel. And it's one of the most popular YouTube channels in terms of popular science in Taiwan. We team up with the Taiwan Physical Society of Taiwan for the International Year of Quantum and Science and Technology. So we have an opening ceremony for the whole year event, and the landmark in Taipei is Taipei 101. So this we can light up the Taipei 101, and so you probably can see it here, but there's a small road. There are some roads for the company of IOIQ. Okay, so we can light up the Taipei 101, and so this event is also broadcasted. And we hold some science fairs. So these are facing high school students, and so they come here and they know about quantum. And we also work with our post office, and we have a stamp. Okay, so this is issued on the Quantum Day, April 13th this year, and we also have the mug. Unfortunately, I cannot bring the mugs to you, but if you come to Quantum Taiwan, I'll give one to you. So this, as you can see, the famous cat. Okay. So we also work together with private companies that they sponsor some of the. So we have a quantum science exhibition at the National Science Museum. It's called Exploring Tiny Wonders. And if you're interested or thinking maybe the whole exhibition can travel around the world, and we can arrange this. So as you can see, there's a model of a quantum computer, and other mentioned, the enabling female scientists is also a very important emphasis on our side. So we have this so-called Q Girls Science Camp. So we invited high school female students, and we have a camp. They basically stay at the National Science Museum, and they have some people come here and tell them about what is quantum. Okay, so these are the efforts we made in phase 1, and our government has already put forward. They included quantum into this future quantum/AI technology plan forward. So we want to continue our research. Our venture sort of like the startups are still lacking, but that's we're in the process of cultivating these startups, quantum startups. So on the research side or on the policy side, for the next phase, we want to continue to develop quantum chips, as we want to leverage the nanofabrication strength in Taiwan, and we want to work together with international partners on quantum cybersecurity, and the emphasis is to do computing. We realize that HPC becomes an important part in the modern age of quantum computing. So we want to develop QC and HPC type in quantum computation. And our government is in the process of procuring a commercial quantum computer. So this is our vision. So as I said from the beginning, we do the R&D. We want to develop global collaboration, and we want to be able to transfer technologies to industry. The final goal is we want Taiwan to be a key partner in the future quantum technology supply chain. And with that, I hope that I convince you that Taiwan can be a key enabler in the quantum era. Thank you.
Thank you. We don't have enough time, but any quick question? Otherwise, let's thank the speaker. Okay. Let's move to next talk. Joo-hee Lee from Korea Institute of Science and Technology Evaluation and Planning. About Korea's R&D investment in quantum technology and quantum research ecosystem development. Please welcome the speaker.
Thank you for having me at this very open meeting that brings together Asia-Pacific quantum experts. I hope today will be the start of the closer collaboration and networking among us. I'm Joo-hee Lee from KISTEP, where I work on policy support for government R&D budget strategy. Here is the title of my presentation. Today, I'd like to discuss Korea's investment and ecosystem development to share our progress in advancing technology as well as potential areas for collaboration and partnership. Here is the agenda for today's talk. First, I'll briefly introduce my institute and its role in quantum technology. Then, I'll talk in detail about Korea's investment and ecosystem in quantum technology. And finally, I'll conclude with a summary. Let's move on to the next slide. KISTEP is the Korea's think tank specializing in science and technology policy and under the Ministry of Science and ICT. This is stated in the framework on science and technology. The vision of my institute is to become a global organization that contributes to economic growth and public welfare through strengthening national STI capacity, national R&D systems, and innovation ecosystems. Our task mandated by law as follows. Mission first, foresight and future strategy for S&T and government R&D program evaluation, government R&D budget allocation and coordination, and feasibility study of government R&D programs. In particularly, for promising strategic technologies such as AI, semiconductor, biotechnology, and quantum technology, we are continuously monitoring developments and identifying emerging issues and addressing them through policy enhancement and improved budget coordination. Now I'd like to move on to the next topic, Korea's R&D investment in quantum technology. Since 2019, Korea has been investing in quantum technology through a dedicated R&D program. Before that, there were many separate projects in this field. Until now, the total investment is about $450 million, and the amount it has been increasing when you look at it over time. By field, the largest investment has been made in quantum computing, followed by investment in enabling ecosystems such as infrastructure, talent development, and several enabling technologies. While the combined investment in quantum communication and sensing is roughly at a similar level. Major investment in quantum computing focus on the development of superconducting photonic neutral atom quantum computers as well as related software. In the field of quantum sensing and quantum communication, funding is directed toward technologies such as inertial magnetometric and electrometric sensors, photonic sensor, quantum memory repeater, and quantum key distribution. For the foundation investment, I already mentioned. The next slide shows an example of funding landscape for quantum computing. The trend is shifting from broad technology diversified support to the targeted investments in specific system level platforms. And this is another example of funding landscape for enabling ecosystem. This is another evolution from limited to enhanced support. This slide shows the major projects dedicated to quantum R&D. Each number corresponds to a project or a sub-project. These projects are interrelated and work cohesively to advance quantum technologies. The area of core technology and infrastructure, National Institute-led R&D programs can be foundation of targeted initiatives, such as flagship project and innovative R&D program. In addition, international collaboration projects are being supported to further advance technological development. Among this, the flagship projects for quantum computing, quantum sensing, and quantum communication were launched this year. The goal are to build 1,000 qubit superconducting and neutral atom quantum computers, as well as 100-kilometer quantum internet with 3 nodes. Let's move on to the last topic, Korea's quantum ecosystem development. First, I'll introduce the governance. There is the Supreme Strategies Council chaired by the Prime Minister. It is the highest deliberative and decision-making body for the national quantum strategy and policy. And there is the framework for advancing quantum technology and quantum industry. The framework provides the legal basis for the establishment of governance and specifies that various policy supports are available for advancing technology and industry, promoting collaboration and strengthening foundational capabilities. It also specifies the establishment of a comprehensive plan for a 5+5-year period. In Korea, the plan for quantum technology has been continuously evolved. This slide was supported by a company CEO who serves as the leader of the Korean Quantum Industry Association. In Korea's quantum ecosystem, there are 3 R&D project management organizations and 6 national institutes and 3 graduate schools of quantum technology and 4 fabrication infrastructure focusing on quantum technology, and about 13 companies currently engaging in the R&D program. As supporting organizations, the Q Center provides quantum talent training and infrastructure, while international cooperation centers in Korea, Washington, D.C., and Belgium promote global collaboration. Next slide shows the R&D actors in Korea. Since the analysis, this is from our institute project, and the analysis was based on the real-time collected data, so there may be some omissions for 2025. In Korea, we have 155 principal investigations currently leading quantum R&D projects. They are mainly concentrated in Seoul and Daejeon. The left side shows us list of R&D institutions consisting mostly of national institutes and companies, with only some universities shown due to limited slide space. To examine the institutions and their major research area in more detail, we selected those whose investment scale exceeds 60 billion Korean won per institute and 3 billion Korean won per technology area for illustration. KRISS is the most active institute leading the flagship project, as well as project on quantum sensing and quantum networks. Their 20-qubit superconducting quantum computer has been successfully demonstrated and has also shown results that surpass the limit of optical measurement using quantum entanglement. KISS demonstrated advanced capabilities in quantum error correction and quantum sensing using distributed nodes and entanglement. Sungkyunkwan University operates the foundation centers such as Quantum Fab and a talent training program, and supports researchers by providing access to use quantum cloud services. and it is one of the frontiers in trapped ion quantum computer development. Actually, is one of the frontiers to develop quantum internet and demonstrated wireless QKD successfully in a dynamic environment. KRISS, which has established and operates the Quantum Fab and Graduate School of Quantum Technology, has taken a step further toward the measurement-based quantum computer by successfully demonstrating 3D cluster entanglement. Seoul National University has been developing both semiconductor spin qubit-based and trapped ion-based quantum computers. The institutions shown in the next slide each focus on their particular area within quantum technology. Korea University is developing a neutral atom quantum computer, while POSTECH is working on photonic quantum computer. UNIST has been establishing a quantum fab, and Yonsei University, which has introduced IBM quantum computer, is actively conducting research on quantum algorithm and software. KISS-T starts to develop a service platform for an IonQ quantum computer and to establish a hybrid computing environment that connects high-performing computers with quantum computers. And GIST has been developing quantum memory technologies. Here are the R&D actors from the corporate sector. This slide presents the 13 companies that are leading quantum R&D projects. Their number has increased, particularly with the launch of projects on quantum sensing, quantum internet, and quantum algorithm. The theme of their projects are written below each company's name. The next slide shows 22 companies participating as project partners, mainly engaged in development of components, quantum sensors, quantum communication, and quantum algorithm. I've been conducting a network analysis to investigate collaboration among institutions, companies, and international partners in Korea. Due to the lack of data on international collaboration, the result has shown part of the picture. In my analysis, two major issues emerged. The first is the need to strengthen collaboration with industry in quantum computing, as collaboration is active in quantum communication and sensing, but remains limited in quantum computing. The yellow cluster in the network graph shows that ATRI, which mainly conducts research on quantum sensing and quantum communication, is actively collaborate with the industry partners. The second issue is how to improve both the quality and quantity of international collaboration. The figure on the right illustrates the international collaboration conducted by the Quantum R&D program. Although several relations are not shown here, the need for expansion is evident. Now, let me summarize the progress so far and outline the way forward. Korea has enacted legislation to promote the development of quantum technology and is strengthening its support accordingly. Building on this foundation, we should further enhance technology collaboration to realize the advancement of quantum technology. Thank you.
Thank you for the talk. Now we can take a few questions. Otherwise, let's thank the speaker again. Okay, we're sorry again that we did not have enough time for this session, so the last talk is postponed to the first afternoon session. And let's thank all the speakers in the session, and again. will have shortly APCTP Benjamin Lee Award presentation by Professor Peter Jola at the conference hall 3 is next this hall, this floor. So let's have some break time. So please discuss with the speakers at break time. Thank you. Please move to the conference hall 3 next to this hall.